In this problem, we look at an application involving sound intensity. The decibel level D of sound is given by the equation G equals 10 log base 10 of the ratio I over I sub 0, where I is the intensity of the sound and I sub 0 is 10 to the negative 12 watt per square meter. If the shout of a single person measures 80 decibels, how loud will the sound be if two people shout at the same time? That is, how loud will the sound be if the intensity doubled? First thing we need to do is determine the intensity. Since the shout is 80 decibels, we need to solve the equation 80 equals 10 log base 10 of I over 10 to the negative 12. We solve this for I to determine the intensity of the sound. Divide both sides by 10. We get 8 is equal to log base 10 of I over 10 to the negative 12. If we convert from our logarithmic form to an exponential form, we get 10 to the 8th power equals I over 10 to the negative 12th power. Then we multiply both sides by 10 to the negative 12. We get that I is equal to 10 to the negative 4th watt per square meter. Now that's the intensity for one person shouting. If two people shout, the intensity is doubled. So we'll get I is equal to 2 times 10 to the negative 4th watt per square meter. We want to find how loud the sound will be if the intensity doubled. We're looking for D in this case. So we'll get D equals 10 log base 10, 2 times 10 to the negative 4 over 10 to the negative 12. This will be 10 times log base 10, 2 times 10 to the 8th. If we put that into our calculator, we'll get that D is approximately 83 decibels. So if two people shout, the sound will be roughly 83 decibels. In part B, we're going to determine the number of people that are required to reach a certain decibel level. The pain threshold for sound is 125 decibels. If the Athens Olympic Stadium 2004 can seat 74,400 people, how many people in the crowd need to shout at the same time for the resulting sound level to meet or exceed the pain threshold? If we let N represent the number of people who shout, then the intensity will be N times 10 to the negative 4th watt per square meter. We're going to let D be 125, since that's the pain threshold, is 125 decibels. If we go back to our equation for D, where D was 10, it was log base 10 of I over I sub 0, we end up with 125 equals 10 times log base 10 of N times 10 to the negative 4th over 10 to the negative 12. Where N times 10 to the negative 4th was the intensity for N people shouting. 10 to the negative 12th was our constant, and we were letting the pain threshold be 125 decibels. We need to solve this for N. We're going to start by dividing both sides by 10. This will give us 12.5 is equal to log base 10 of N times 10 to the 8th power, using rules for exponents. If we convert from our log form to an exponential form, we'll get N times 10 to the 8th power is equal to 10 to the 12.5 power. Divide both sides by 10 to the 8th, we'll get N is equal to 10 to the 4.5 power, which is approximately 31,623. So if we have 31,623 or more people shouting at the same time, we will meet or exceed the pain threshold of 125 decibels.